MQ series on all platforms. That's what makes him uniquely qualified to talk about MQ series, because he's actually used MQ series on all the different platforms where MQ series runs. And he's written applications in it, and he has directly supported it for a number of years. So, Ron, I'm going to go ahead and turn this over to you.
Okay, I'll be driving here. My name's Ron Bauer. I work with Paul. This lecture is going to be on WebSphere MQ series. There was a question earlier in the chat about the differences between ZB2 on LUW and ZOS, and the truth of the matter is they're quite a bit similar. And the same thing is true with WebSphere MQ. No matter which platform you learn it on, the product is very, very similar among the different platforms, which makes it easy to learn on one platform and then transfer over to another one. So in this unit, the things we're going to cover, you should be able to define a message, a queue, and a queue manager. You should be able to explain asynchronous communication, and you should understand what WMQ channels are. And sometimes I'll call it WMQ instead of WebSphere MQ. And so WebSphere MQ, the product itself, allows two programs to communicate to each other using message queuing. And what message queuing is the programs basically send messages through queues to each other as opposed to direct API calls. So there's the definition of messaging. Programs communicate by sending each other data in messages rather than a direct call. And the queue is where the messages actually get stored while the programs are waiting to receive them. So asynchronous communication, you may already be familiar with asynchronous communication. And what that is the caller and the server are decoupled. So you've got two programs running, and the server does not need to know where the caller is, and the caller does not need to know if the server is available. So you just kind of make your calls, and there's a very loose binding between the caller and the server. Getting back to that direct, we don't do it directly. We put the message on the queue, and the server and the caller are decoupled. Think of voicemail. You can call somebody. They may not be on the phone. You leave a voicemail, and they can pick it up later at their convenience. So asynchronous communication works for a lot of things. There are times when you have to have synchronous communication. Paul mentioned that during the CICS when there was conversational and pseudo-conversational. They both have their area where they're better than the other one. They have advantages, clear advantages, and the same thing is true with asynchronous communication. And you can even use WebSphere MQ pseudo-synchronously, even though it's being done asynchronously. So what is a message? A message is a unit of data that's being moved from one application to another. So one application would build this message. Think of just building a buffer, in memory, and then you give it to WebSphere MQ, and WebSphere MQ will put it on the queue, and then another application will come along and get that message. What's in a message? The answer is anything. It can be binary. It can be text data. The text data could be record kind of stuff where you see fields. It could be XML. It could be a C structure. It could be a COBOL copybook. It doesn't matter what it is. One of the things that WebSphere MQ does is it does not look at your data. So it doesn't really know what it is. You make a call to MQ and give it the message. It puts it on the queue. It has no idea what's in the message. Now, I'll go ahead and say that over time, we found more and more of our customers actually wanted to do something with that data in flight, in between the sending and receiving application. And because of that, we now have a product called the WebSphere Message Broker, which just got renamed. I can't remember the name off the top of my head. But what that broker does is it actually looks at messages and makes changes to messages. So you might have an ID come in, and the other receiving program doesn't know what the ID is. You want it to look at a name, and so it would go out to a database and change the ID to a name and put it back on the queue. So that's the message broker. But MQ itself does not look at the message. It can be anything. There's the name of the new name of it, the IBM integration bus. Thank you. What types of messages can you send with WebSphere MQ? WebSphere MQ defines 4 types of message. A datagram is a message for which no reply is expected. And for me, when I think of a datagram, I think of being at an airport and looking up there at the departures and arrivals monitor. I'm going to be sending that message out every 2 minutes, every 5 minutes, whatever it is. and I don't expect a reply. I'm putting it out there. If you don't get it, I don't care. I'm going to send you another one in a few minutes. So no reply needed. A request, I am actually expecting a reply. So this might be a bank type message where you're requesting from the bank your account balance, and you actually expect a reply to come back from that, which is what the next type of message is, a reply. A reply is what you get back to a request message. And then a report, these are used for when you multi-hop a message, maybe from point A to B to C to D, and you want to know, hey, did it get to B? Did it get to C? Did it get to D? You can get a report message that'll let you know where the message is, how far it's kind of gone through the network. And you can also get a report message when the receiving application actually picks it up, a confirmation of delivery. So those are the 4 types of messages. They all have their place. You got to look at your application and figure out what's the most appropriate type of message for what you're doing, and then that's what you do. Queues, I mentioned this earlier. Queues are where messages are stored. So if you want to send a message to somebody, it's got to stay somewhere while waiting to be picked up, and a queue is where it's going to stay. They are a named entity which hosts a collection of messages. So when you look at WebSphere MQ, one of the things you do is you name your queue. So you might have a payroll queue, an accounts receivable queue, an accounts payable queue, those kinds of things. In general, queues are, the messages on queues are first in, first out. However, you can set the queue to be delivered by priority. So you can set a higher priority message and a lower priority message. You can also, if you have a message ID, get the message directly regardless of the type of order that's on the queue. There are several types of queues. A local queue is a queue that exists right here on my local queue manager. So it's where I would put messages. An alias queue is a level of indirection. So we mentioned views earlier with DB2, which is really a view into a real table, kind of an alias into a real table. A queue is kind of the same thing. You might specify an alias queue, and then people would put messages onto the alias queue, and then underneath the covers, MQ would put it on the real physical queue. A remote queue definition is not what I would call a real queue. It's not a physical queue. And what it is if you have 2 queue managers, a local queue manager and a remote queue manager, the remote queue gives the definition on how to get the message over to the other queue manager. A model queue, in situations where you have maybe a lot of clients connecting to a queue manager, you may decide you don't want them all to have their own queue. And so you would define a template, a model queue, and then each client could connect in and say, give me a queue that looks like the model. And then they would get their queue, they could do their work, and when they go away, their queue would go away with them. And then a transmission queue is a special queue that's used by the queue manager to talk to another queue manager. So I mentioned local and remote. So if you're trying to get a message from a local queue manager over to a remote queue manager, you would use MQ would use a transmission queue to get that message over there. A queue manager, I've already talked about a queue manager quite a bit. A queue manager is basically a collection of queues and their messages. It's the process that's kind of in control of everything that's going on. A queue manager communicates with another queue manager using a channel, and we'll talk some more about channels here later, but basically it's a reliable transport mechanism. It's a TCP/IP communication between 2 queue managers for sending messages from the local queue manager over to the remote queue manager. What does MQ provide? MQ provides exactly once message delivery, once and only once message delivery. Last thing you want when you're in an environment where you're sending messages back and forth is for you to send a message and not know if it got there. And it could be a problem if it doesn't get there, and it could be a problem if it gets there twice. So MQ is, exactly once message delivery. It allows loosely coupled applications, asynchronous messaging. And when you look at that picture, you see A and B with queues in between them. A can put a message on the queue for B, and B may not be around. When B comes up, B can get the message and put it on a queue for A, and A may not be around. So it's asynchronous. It provides a single multi-platform API. Once you learn to use the MQI API, you know it on all the platforms. It's network independent. There's nothing in the API about the communication protocol that MQ might be using underneath the covers. and because of that, it gives you faster application development. And because the API it's different, a little bit different for each programming language, but you make the same API call. So even if you've written in COBOL and you've never seen C, you can pick up MQ programming on C very quick. The API is very, very similar between the different programming languages. And then it's universal. It runs everywhere. And I haven't seen a recent chart. So depending on how you count things, MQ runs on over 30 platforms. It runs on all the variations of Linux. It runs on AIX. It runs on Windows. It runs on ZOS. It runs on AS400. There's other ones as well I'm sure I'm leaving out. Sun, Solaris, HP Unix. So it runs everywhere. And because the API is, consistent, it makes it great for developing applications. I don't know, does it?
If once Bruce asks a question, you might want to repeat the question.
Yeah, Bruce asked a question about it running on an platform that it runs on. I'm not sure if it runs on it or not.
Because right now it goes to mobile, right? So on Q, I think it runs on iOS and Android.
And so Bruce
is surprising if it runs on Android.
Yeah, Bruce is asking about it running on iOS and Android, and it does do mobile. So it's got to do something with it. I'm not sure of all the details on that. This picture looks a little bit mangled, to be honest. What this is trying to show is asynchronous messaging. And so when you look up at the top there, you have the logical connection between A and B, and that's what I would call synchronous communication. A and B have to be up and running all the time. So A, sends a message to B, B replies right back. Down below, what you'll have is this message and queuing environment, and so A puts a message into the message and queuing environment, and B may not be able to pick it up right away because B's busy, or maybe B's not even available. Maybe B is a batch program that runs at night, and so until that evening, it's not even going to come up. It doesn't matter. A can still put its messages out there, and then when it comes time for replies, A may or may not be ready to receive the reply. So the two programs do not have to be in direct communication with each other to send these messages back and forth. Mentioned the queue manager. We mentioned DB2 earlier, and when you think about DB2, talked about tables and rows and records in DB2. You do not write directly to the files, the vSAM files that DB2 has under the covers. You call DB2 APIs, and DB2 takes care of writing to those files. And so that's what that first, set of boxes is. A program communicating to DB2 to get the data out there. MQ is the same way. You don't put messages directly on the queue. You talk through the queue manager using the MQ APIs to get messages on the queue. And so down below, logically, what you have is a program logically putting and receiving messages onto queues. But in actuality, it's going through the queue manager to do it, just like a program would go through DB2 to do it with DB2. I mentioned the WebSphere MQ API, and here's an example of that. And it's called the MQI. And so I've got a program that is trying to talk to a queue manager, and there are the sets of APIs that it can use. And so there are some APIs that are associated with connecting to the queue manager itself. So you MQ con to a queue manager in order to do anything. You MQ disk. You disk connect from a queue manager when you're done. MQ conx is a special connection which allows you to get away with doing some special things. We'll just let that go with that for now. MQ open and MQ close. So once you've connected to a queue manager, if you want to do something with a queue, you open the queue, and when you're done, you close the queue. So MQ open, MQ close are what you use to get a hold of a queue. MQ get is what you would use to get a message off of a queue. MQ put is what you would do to put a message onto a queue. And MQ put 1 is a special call. If all you're going to do is open, put a message, and close, MQ put 1 allows you to do that in one API call. The commit, back, and begin APIs are used for units of work. So if you are getting and putting messages inside of a unit of work and you've got to the point where you realize you're done, you can commit that unit of work. If you get to a point where you've got some kind of problem, you think, I need to roll everything back, you would MQ back. And then MQ begin is what you would do to start that unit of work. And then MQ INQ inquire and MQ set are a couple of special API calls that allow you to inquire and set some things on some of the MQ objects. So if you wanted to maybe look at something on a queue, you could do that. And so you use all those API calls to talk through the MQI to the queue manager to get your work done. So I mentioned local and remote queue managers. Over on System 1 on the left, we have two programs, Program A and Program B, which are talking through the MQI to a queue manager, which is the box kind of below. And so what you have is Program A can do a put, and it can go out to Q1 on Program A, and then Program B can do a get and get a message off of Q1, and that is all local. That's not remote. However, if you wanted to put a message onto System 2 where Program C could get it, you would have to use an XMIT queue, a transmit queue, and you would put the message out there, and MQ would use TCP/IP as a protocol to get the message over to Q2 where Program C could get the message. That would be a remote queue manager. So System 1 messages back and forth between A and B are all local. Program A talking to Program C would be remote. You know, the last slide kind of waved its hands a little bit. It didn't go into a lot of details, but here we've got Program 1 and Program 2 on two separate queue managers, so Queue Manager A and Queue Manager B. And if you really want to get a message over there from Program 1 over to Program 2, you see the XMIT queue, and we talked about that. But under the covers, what MQ is using is what's called a channel. And so channels work in pairs. So if you want to talk from Queue Manager A to Queue Manager B, you have to have a channel on A that's a sender to B, and B has to have a channel that's a receiver. So I've got a sender-receiver pair that gets me from A to B. Well, if I want to put a message back from B to A, I need another set of channels, another sender-receiver pair. And so I would have a sender on B that would talk to the receiver on A. So nothing, difficult here. It's just that you just need to have a pair of channels on both sides to get messages back and forth between two remote queue managers. And then one of the things we have going on under the covers is how many resources do you want running at any given time that aren't doing anything. And so what MQ does to take care of that is it has a special process called a channel initiator. Now this channel initiator, and when you look at this picture, basically is getting one MCA, message channel agent, one pair of channels to talk back and forth between each other. And there's not a lot of value in running the channel initiator here, but if you had a queue manager that was talking to maybe 50 other queue managers, you wouldn't want all 50 channels running. And what the channel initiator does is it waits for a message to hit the transmission queue. And when it hits the transmission queue, what it does is it then fires up the channel pair between the two queue managers. They process the messages, they wait a little bit, and then they shut down. So it's just a way to save some resources to have one basically process running at a time to keep track of a whole bunch of processes that may or may not need to run. And when they do, it starts them up. So the channel initiator is MQ's way of taking care of that. Here we are in a sysplex environment. We've got, I guess, quite a bit of connectivity here. I can have the queue manager on ZOS1 talk to the queue manager on ZOS2, but I can also go out and talk to queue managers on other platforms. So here I've got an MQ queue manager on AIX, I've got an MQ queue manager on Windows, and I can have these queue managers talk back and forth between each other. So there's no limitations regarding, a Z queue manager has to talk to a Z queue manager, or Windows can only talk to Windows, or Windows can only talk to AIX. They can talk, any queue manager can talk to any other queue manager on a different platform. All you need to do is set up a pair of channels between them. Let me go back one slide. One thing you could have done here this slide doesn't do it, is we could have had the AIX Queue Manager be connected to Queue Manager 1 and Queue Manager 2, and the Windows Queue Manager could have talked through the AIX Queue Manager to Queue Manager 1 and Queue Manager 2. So there's nothing that says the Queue Managers have to be directly connected. It's possible to hop through an intermediate Queue Manager. So a Windows could talk to an AIX, which talks to a Z.
And Ron, this is Paul. One thing that, so I'm imagining an application for that. I may have a giant department store. Each one of the point-of-sale devices has a WebSphere MQ client on it, talking to an in-store controller that might be a WebSphere MQ AIX. In that store, WebSphere MQ AIX could be talking to my host site for all the stores.
That's a good example. That's a very good example. And something else about that example is it's entirely possible that you would not send every single message off of your AIX Queue Manager up to your back office. You may wait till 5 o'clock or till you get 100 messages or something else, and then automate the processing of that message so that you don't have that connection coming up and down all the time. There's a question in the room.
Could it be one-to-one or one-to-many?
So the question is, can this be one-to-one or one-to-many? And the answer is it can be one-to-many. I mean, it can actually it can be many-to-many. You can have, you know, a Windows Queue Manager talking to 10 other Queue Managers, and those 10 other Queue Managers, you could have 10 Queue Managers all talking to each other. You know, one of the things WebSphere MQ has going for it is a rich set of adapters. We're talking about the CTG, the Kix Transaction Gateway. Well, there's actually an adapter that allows you to talk from MQ, or from CICS actually, out into MQ to get messages back and forth. So that's one. There's options. There's adapters for IMS. There's just adapters for all sorts of things, you know, and you'll find an adapter to get you in and out of the WebSphere application server. So depending on what you're trying to do, you can get out of MQ into just about any kind of environment. Here's an application scenario. I've got 2 Queue Managers running, and what I've got is I've got a query message that I want to send from my application, my payroll query application, and so I might put it on my payroll query remote queue. Well, that's not a real queue. That's a queue that just has enough information to get me onto my transmission queue, which is what I have to use to get my message over to Queue Manager 2. And so this system channel init queue is my channel initiator. I see that a message has come in, and I use the QM1 to QM2 channel to get the message off of Queue Manager 1 over to Queue Manager 2. And on Queue Manager 2, I put it on a local queue called payroll. Well, that's where my payroll processing application is reading from. So my payroll processing application would read that message, it would figure out what needed to be done, and it would send a reply message back. And I would follow basically the exact same process, only in the other direction. So I'm going to, you know, put this message out onto a transmission queue, which is going to have an initiator queue that's looking at it. It's going to go from Queue Manager 2 to Queue Manager 1 through the channel over to the local reply queue where my query can pick the message up. So that's in you know, all the steps basically in getting a message from a payroll query application on one Queue Manager over to a processing application on a second Queue Manager. So now we're getting into some of the commands to actually start the MQ series Queue Manager. We mentioned subsystem IDs earlier, the DB9G. Here's CSQ7 to start a Queue Manager, and when you do that, you can see the list of what's going to come out in the log as you're actually starting the Queue Manager. I think we're actually going to do this, right, Paul? Are you going to bring up the Queue Manager?
Yeah, we can bring up the Queue Manager.
You know, I mentioned the channel initiator. Here's the command to start the channel initiator. Each MQ environment has 2 address spaces, so it's got the master address space, it's got the channel initiator. So I mentioned that earlier. The channel initiator allows you to, you know, minimize what you have running by just having that one process up to keep an eye on things, that one address space up to keep an eye on things. Anything you start, you need to be able to stop. So here's the commands to stop the channel initiator and to stop the Queue Manager. If you want additional information There's the MQ version 7.5 info center that's out there that's got quite a bit of information in it. There's also a red book called the WebSphere MQ Primer Red Book. It's 50 pages. It's a very high-level red book, but it gives a very good overview of MQ and what you're trying to do and how you're trying to do it. And then here's some more links to some documentation. And I believe there's one other chart here. No, two more charts actually. So we defined what a message was. We defined what a queue was. We defined what a queue manager was. You know, queue managers holding all these queues, and the messages are what applications are passing back and forth among themselves. You know, asynchronous communication is where the two programs don't have to actually be directly connected to each other. They can communicate through a queue, and not both of them don't have to be up at the same time. And then WebSphere MQ channels are the things that MQ uses to get messages back and forth between two queue managers. And lastly, there's the concept of publish and subscribe. So everything I talked about prior to this was point-to-point messaging. Publish and subscribe is a little bit different, and we're seeing more and more people wanting to use publish and subscribe. And basically, what publish and subscribe is somebody subscribes what they're interested in, and somebody else publishes on a topic, and if you subscribe that you're interested in that topic, then MQ is going to hand you the message. And so there's a set of APIs around that. So MQ sub says, hey, I'm interested in subscribing, and you would say what the topic is that you're interested in subscribing on. MQ sub RQ says that you want to subscribe and you want to request to retain publication. And that comes in handy for getting the last thing published. If you just start subscribing today, you don't get a publication to you until something comes in. With the RQ, you get what was last published. So it may have been published a day ago. You'll still get that to kind of give you a feel for where things might be going history-wise. And so here, in this scenario, I basically got, you know, program A that's doing a publish into the queue manager. And when it hits the queue manager, A is going to go ahead and pass that message, or the queue manager is going to go ahead and pass that message out, in this example, to C, E, and F, being the three people that subscribe to that actual publication. So publish and subscribe, it comes in handy. You know, this is very similar if you know Twitter to following somebody. You know, when you follow, basically you're subscribing, and when you tweet, you're publishing. And you can go look and see who's subscribing, but the truth of the matter is, at any moment in time, you really don't know who is subscribed to you without looking. You just kind of publish, and whoever gets it, gets it. So publish and subscribe. It's coming in, like I said, a lot of people are finding a use for this these days, where it used to just be point-to-point. I believe that is the last slide, yes. So I'll go ahead and turn the machine back over to Paul here.
Okay. Thanks, Ron. And let's see if I'm surprised I failed to put a follow-up slide in there, because the very first slide talks about what we were going to accomplish